Okay, on the next couple of examples, we're going to be identifying and talking about some of the same stuff that we've already been talking about, but we're going to figure it out without graphing, like especially even domain and range. Now, one thing I want to remind you of is here you're asked about max or min value. I had you to take a note a while ago, remember, that said the value itself is just the y coordinate, okay? Where it says, of course, determine the value, so that's going to be the y coordinate. Where it occurs is going to be like, is it a max value or is it a min value? Okay, so on this one I already have a little bit of it written down. But identifying some of the information that we talked about earlier, your a value for this, of course, would be the -2. Since it's negative, that means your parabola opens down. So I've just sketched off a graph that does turn down, because if your parabola turns down, that forces your vertex to be at the top. So if it's at the top, therefore it would have to be a maximum point, which means you're going to have a maximum value. But what we've got to do next is actually find the value. Now, the value again is just the y coordinate, but I'm actually going to have to find x first anyway. I'm going to end up knowing the whole vertex. But I'm going to say vertex, but in a minute I'm actually only going to write down just my y value as my answer. Alright, so we've got -b divided by 2a. Alright, so b is going to be -12. And a, as we've already said, is the -2. So we have 12 divided by -4, which is equal to -3. So now I need to take the -3, substitute this back into the problem. Okay, so let's do our calculations here. Let's see, we're going to end up with $21, if I did my calculations correctly. Alright, so my vertex is the point -3, 21. Okay, but again, going back to the question that's asked, first of all, is it a max or a min value? So we've already determined it would have to be a max value, but the value itself, remember, is just the y coordinate, the 21. So we have a max value, and that max value is 21. Okay, so this is one thing that we were asked to identify. Now, we're also asked to identify domain and range. Of course, a while ago, I mentioned about domain. On all those other problems that we've worked so far, our domain has been negative infinity to positive infinity, and I told you it would be all the time because these are all polynomials. Now, range, we'll have to do a little thinking here. Now go back up to my graph. I already know that this turns down, which means it goes down forever. So my range would have to start off at negative infinity, and it's going to come all the way up to the vertex. Now, range is y, so all you need is the y coordinate of the vertex, which we figured out is the 21. So here's your domain and range that you were asked for, and then the value and where it occurred. Of course, where it occurs just means whether you're deciding whether you have a max or a min. Okay, another one of these real quick. Okay, so on this one, again, let's identify our a value. So a is going to be the 6, so that's positive, which means that my parabola is going to open up this time. Okay, so if I were to sketch off a parabola that opens up, my vertex is here at the bottom, so this time I'm dealing with a minimum point. Okay, so I do need to find my vertex. Of course, this will require use the same little formula I did just a minute ago, the negative b divided by 2a. So I would have negative 6 divided by 2 times 6. Okay, so I have 6 divided by 12, which is 1/2. So now I have to substitute the 1/2 back into the problem. Okay, so let's calculate this. And this time I have negative 3/2. So my vertex is 1/2, negative 3/2. Okay, so we've already decided we have a minimum point, therefore we would have to have a minimum value. And the minimum value, as I've said, if it asks for just the value, then it's just your y-coordinate. Anytime you come across anything that refers to the value of something, it's always going to be in reference to your y. Okay, so now domain and range. Okay, so we should be used to the fact that your domain's negative infinity to positive infinity. Now your range. Now this time my parabola opens up. It doesn't go down forever. So if this were on a coordinate plane, this would be the first y value that's being used by this graph, when you look from the bottom to the top. So the y value was the negative 3/2, and then it goes up forever. So there's your domain and range. All right, one last thing. We've got us a word problem here to look at. All right, you have 200 feet of fencing to enclose a garden. Okay, so that's in reference to like 200 feet as far as perimeter, because you're enclosing the garden. But yet then it turns around and says to find the length and the width that will maximize the area. All right, so first of all, let's draw us off our rectangle here. So you got a total of 200 feet to go all the way around. What I'm going to do is call this side X.